All right, folks. It is 2 p.m. EST, so I think we will get the show on the road here. Welcome everyone to our December webinar. Thank you so much for joining us. My name is Matt Del Bono, and I'm an extension support specialist with the Glaze Consortium. And today we have a presentation from representatives from the U.S. Department of Energy on the New York, New Jersey Onsite Energy Technical Assistance Partnership. Before we get started, I very quickly just want to welcome you all here today with a little bit of information about Glaze. So Glaze is the Greenhouse Lighting and Systems Engineering Consortium out of Cornell University. And we are here to transform greenhouse lighting and systems management to support climate smart CEA. And we do so by conducting research and educating growers so that emerging technologies can be adopted faster and hopefully help growers save money and reduce the environmental impact of energy use in greenhouses. So these are the three main ways that we serve our members. As I just mentioned, our research is focused on greenhouses, but we also work with indoor agriculture, and we seek to help technology transfer through showcasing the results of technology's impact on plants. We also provide a variety of webinars, our annual short course, and other workforce development initiatives to help educate growers. And finally, our membership values our various networking benefits via our member meetings and our annual summit. Our members are very valued, and we hope that you are interested in potentially joining Glaze. And so if you would like to learn more about Glaze membership, you can contact our team or write me directly for additional information about membership benefits and the various categories that are available. And lastly, I want to highlight a new membership initiative this year called Vivid Canopy, where folks working in the CEA industry can connect and organizations can showcase how they are leading by example and hiring a more diverse workforce. Our next event will be a panel and roundtable discussion at Indoor AgCon on March 11th, 2025, and we hope to see you there. So with all that being said, we can switch gears here. Today, we have Dr. Jim Freihaut, Chair of Penn State's Department of Architectural Engineering and Director of the U.S. Department of Energy's New York, New Jersey Onsite Energy Technical Assistance Partnership, as well as Tom Bourgeois and Jacob Seiler to share some of the benefits and opportunities with the Onsite Energy program. So I know that there is a lot to cover, and I'm going to turn things over to Tom to kick things off. So Tom, whenever you're ready, please feel free to share your slide deck and say hello to our audience. And
I think
while you're doing,
I'm sorry. I'm gonna Jim will kick us off.
okay,
Yeah.
excuse me, thank you.
No problem, no problem.
And while you're doing so, folks, I'll just remind our attendees that we really appreciate questions. Please feel free to submit your questions via the Q&A as the presentation goes, and we will save time at the end of our time here to address those. So thank you for tuning in, and Jim, yes, please, whenever you're ready.
All right. Thanks very much, Matt. Yeah, I'm representing at this particular webinar the U.S. Department of Energy, New York, New Jersey On-Site Technical Energy Assistance Partnership. I want to tell you a little bit about that program and what its potential relationship is to controlled environment agriculture. Our on-site energy program, it's a DOE-funded program. There's 10 of them around the country, as you'll see in a minute. And our job is to promote the use of distributed energy technology in various forms in terms of energy generation or energy storage at a particular site, as opposed to business as usual, which is hooking into a central grid and using a separate source of fossil fuel for heat at a particular facility. In our particular case, we can use, or we promote the use of a combination of technologies at a site to make the site as independent energy-wise as it can be from the centralized systems. And the reason for that is not just to increase resiliency, but also to reduce carbon footprint relative to the electric grid, the central electric grid, increase energy efficiency, and to reduce the cost of running the facility. So we call it E cubed: energy efficiency, economics, and reduced emissions. And you generally have to use a combination of technologies at a site to meet the various types of electric or thermal energy needs at a site by a combination of technologies to do it efficiently and economically feasible manner. So we used to be called the Combined Heat and Power Energy Program, but we've expanded that into all forms of on-site energy, battery storage, on-site generation of energy with an engine or a recip engine or a gas turbine or even a fuel cell, um, geothermal heat pumps, geothermal energy sources, high temperature heat pumps, renewable fuels, solar PV. So just any configuration of technologies that can be combined together in a feasible manner, economically feasible and controllable manner to meet the on-site energy needs of a system. We give advice on that. So our charter is to give technical assistance, to engage end users in implementing technical assistance, and also to educate policymakers, regulators, public utility commissions as to objectively what are the best set of technologies that should be made available to users in the utility to benefit society, increase resiliency, and reduce emissions. So we don't have any particular technology that we promote. Used to be more focused on combined heat and power, but not so much anymore, although we still do combined heat and power. And we, free of charge, will come into a site and look at your energy demands and your energy cost and make suggestions on what sets of technologies you could use to meet your electrical and thermal demands by using a configuration of on-site energy technologies. And we do an economic assessment, a technical assessment. It's free of charge. And the whole point is to reduce emissions, increase resiliency, and make you more economically competitive. So we also engage with a lot of end user organizations, such as engine manufacturers, solar cell manufacturers, et cetera, to get the latest information on the characteristics of their technology and how it can be applied. Again, we don't have any skin in the game in terms of any particular technology. You can see over here, there are 10 of these systems, 10 of these on-site energy centers around the US. And the reason for that is the cost of energy varies so much. The availability of energy varies a lot from region to region. And the weather varies a lot. So an on-site configuration is not one size fits all, but it has to be adaptable to the different economic and regional conditions. That's just the contact information there. That's boring. You can look that up. Why is on-site energy important? Well, I tried to mention already, it's a more sustainable way of using primary energy to reduce the amount of primary energy you have to use at the site. It usually is interactable with the grid, although in some cases it can be totally separated from the grid in times of a grid outage, but usually they run in parallel. So it can either import or export electricity to the grid. So that makes the grid as a whole much more resilient. Generally, you get a cost savings relative to your electric and thermal energy costs at your site, but not always. And that's why we have to do the analysis. You certainly will increase your resiliency in terms of being able to operate independent of the grid or recover much more quickly from a grid outage. And generally, these things are done in the context of a community engagement. We'll give a couple examples of that later on. So our services are to identify the possible sites where on-site energy could be used in an economically and technically feasible way, help you with the screening of that, do an initial economic analysis, do an initial analysis of the regulations that would apply to that particular site. We can get you started on design and development. Or if you go through with an actual full-blown design, we can look at that design later on. We won't do it ourselves, but some engineering firm would do it, and we can cross-check or double-check or provide a third-party review of those design and development documents. We help you with the procurement process in terms of incentives that might be available from the state or federal government or even a local utility. And we can give suggestions on operation and maintenance. Kind of a full service initial assistance. So the way to engage us is to contact your regional technical assistance partnership. Like I say, this is all on the web and DOE site. You can, if you're not from the New York, New Jersey area, there are 9 other sites around. All that contact information is there. We would discuss with you the site characteristics, collect data. The more data we can get, the better we can do our analysis. We conduct the analysis and review the results with you from an economic and a technical perspective and an emissions perspective. A lot of people are interested in reducing their scope 1 emissions now. We do scope 1 emissions, but we also do scope 2. In other words, what's the footprint of the electricity coming into your site from the grid? And then take a look at the total scope 1 plus scope 2 for your different configurations. So we give you actual numbers back in terms of taking a look at the component technologies that might be available at a particular site and look at the reductions in emissions and the payback periods that would be associated with those technologies and what the component cost would be, first cost and energy costs. So we've done a lot of different facilities around the country, different types, especially in the New York and the Mid-Atlantic area. And the types of facilities that are usually most amenable are those that have consistent thermal and electric demands. The more coincidental, the better. High thermal demand is good. And we meet the thermal demand and then take what electricity we can from the array of technologies producing electricity at the site, particularly the combined heat and power component of that technology. And we work with the specific on-site facility manager and investors and owners and the regulatory agencies of the site and the particular agencies providing incentives for that site. So it's full service, basically a full service, cost-free service provided by the DOE to try to promote distributed energy. And with that, I'll turn it over to Tom. I'll stop sharing my screen, and Tom?
Yes. Let me take a moment here as here we go. All right. I think Jim whet your appetite there with the description of our no-cost suite of services, and I hope I can do it one better here because I'm going to talk about not only is it a no-cost service, but it may actually come with an incentive grant. I'm going to give you a brief review of that possibility, but for those interested, next week we have 2 deep dive webinars on this topic on December 17th at noon and again at 2, where we'll have the DOE headquarters person and myself talking about the program for a full hour. But I'm going to speak a little bit about 2 matters. First of all, I'm going to talk about this program. And secondly, we're going to talk about how we think CEA might play a particularly important and innovative role in the grid of the future. So I'm going to discuss these. This is the Industrial Assessment Center's implementation grants. This was funded by the BIL, the Bipartisan Infrastructure Law. 80 million in funding was available in the first year. 400 million was allocated, and the amount of the grant is 300,000 per grant per quarter. This is done on a rolling basis every quarter. So right now, applications are being taken for the quarter ending 12/31. Winners will be confirmed early in January of 2025. I will know more for sure at next Tuesday's events at noon and 2, but last we heard, we expect these to run throughout each quarter throughout 2025, if not longer. And again, 400 million was allocated, and there's a lot of money sitting on the table. Last we heard, we'll get an update next week, but last we heard only 40 million had been allocated of that money. So there's plenty there to be had. I want to point out a couple things here in that middle bar. Um, this requires a contribution cost share, but that can be in-kind contributions and so on. It doesn't necessarily have to be cash in your pocket. And it's $300,000 per period. So, for example, if you get an engineering audit done by our center, and we are one of the tickets, we're a gateway to getting this. You have to get an audit done by a certified auditor. The Onsite Energy TAPs are one of those certified auditors. If you have an audit, you can use our audit to submit. Suppose we give you several recommendations. You can suggest one project in 2024 Q4, and then you can come back in 2025 Q1 with another one. So you can actually leverage several $300,000 contracts. Now the bottom line I want to point out, this says for small and medium-sized manufacturing and wastewater treatment. I want to absolutely make sure that you realize that this also includes all forms of CEA. You are included in that definition of the industrial sector. And I know this for sure. We actually did an audit some time ago for a greenhouse in Berlin, New Hampshire, which took our audit, submitted, and won an award. So I know that high-tech greenhouses and CEA are applicable, are able to apply for this. So for the requirements include gross sales of less than 100 million, less than 500 employees, and annual energy bills of at least 100,000, and no more than 3.5 million. So far to date, and these numbers are a little bit out of date, but about 162 awards were made across 36 states. About 26 million. I understand that number's up a little bit since that time. And here's some examples of what some of the projects awards were for: HVAC boiler upgrades, electrification, VFDs, combined heat and power, and so on, other forms of on-site power. And as I mentioned, we are one of the gateways to getting this. If you have, we're option number 2. If you receive a no-cost screening assessment from one of our on-site energy centers, you can use our audit to make an application for that award. So next, I'm going to tee up a little bit more specifically here about CEA industry, and then turn it over for more of a deep dive with Jim and Jacob. I don't have to tell you all, and I thought Jacob put it very well. Jacob says that we're looking at what's happening immediately outside the greenhouse. And one of the things immediately outside the greenhouse is the radical change occurring in energy markets at this time. Many states have embraced an emissions-free power grid and eventually a carbon-neutral economy across all sectors. New York, for example, mandates a 100% zero-emission grid by 2040 and net zero emissions for all sectors by 2050. New Jersey actually moved that up a little bit. They want a 100% zero-emission grid by 2035. And one of the items that I'm going to focus on, and this is actually as much a question as it is a declarative statement, but we have the sense that a properly designed and configured and operated high-tech greenhouse could serve as a dynamic grid asset. And we're going to put forth that hypothesis and ask you all what you think. So even with an unprecedented build out of solar, wind, and energy storage, this is quoting New York, we still are going to have a need for, there's still a wide gap in what the New York ISO calls DFRs, dispatchable, distributed, emissions-free resources. So even with, this is the most recent New York ISO Energy System Outlook, we are looking at 3 times, installing 3 times today's current installed capacity of 37 gigawatts. We're looking for 100 to 130 gigawatts to meet demand by 2042. And among that number, we're going to be needing almost at the very low end, 20 gigawatts to as much as 40. I believe that the New York ISO's baseline estimate is about 35 gigawatts of these dispatchable distributed resources all across New York State. which are absolutely necessary. That's the bottom line. These defers are critical to address the attributes required to run the grid. And this is a quote from the ISO: a zero emissions grid requires technologies that can fill in when wind and solar are unavailable resource. These resources can pose challenges to grid operators that must balance supply and demand in real time. So um, about this time last year, almost this exact date, there was the New York Public Service Commission, DPS, held a technical conference on what they called the gap. The gap being even after we build everything that we expect to build by 2040, what do we still need for a reliable grid, a resilient, reliable grid? And these were the 10 factors that the New York ISO enumerated. And a dependable fuel source, non-energy limited, quick start, dispatchable. It can take a signal from the grid. It can ramp up. It can ramp down. It has to be flexible across a wide operating range. It has to be fast ramping, et cetera. You can see this. These are the 10 characteristics that need to be accounted for in this grid of the future, these resources in the grid of the future. Now, I just focused on New York, but we're witnessing a huge spike in power demand nationwide. So I put over here on the left-hand side, this is the PJM progression of power demand forecasts. The PJM forecasts in 21, 19, 20, 21, 22, 23. And you can see this steadily rising forecast. This is true no matter where you look. I saw something else just yesterday about an extraordinary amount of new demand being created by electrification, being created by power consumption demands of AI. So what we see here that there are some real challenges. The projections of annual load growth are markedly above trend. It's caught the utility industry by surprise. PJM, for example, and this is going to be reflected in your costs. PJM capacity prices, this was from late July, they increased nearly tenfold in the 2025-26 residual auction. That was characterized as a, quote, caused by a trifecta of load growth, generation deactivation, and challenges to risk modeling, all shrinking reserves. So the value of dispatchability will become ever more critical going forward. So one of the hypotheses that we have that we would like to explore with you here today and tee up, and then Jacob is going to talk a lot more. He's in the last stages of modeling towards his PhD. We feel that there may be an opportunity here for appropriately designed, configured, and operated CEA systems that can simultaneously address growing greater food, utilizing circular economy principles, that is, utilizing biogas, organic waste, and perhaps thermal recycling, co-location next to industrial or next to data center processes, all in this case having to do with meeting this pressing imperative of developing these dispatchable, fast ramping resources. I keep referring back to New York because I think they've probably modeled it more intensively than any other state, at least that what I'm aware of. But we see in New York and have we can show the scale here. We essentially have to rebuild all the capacity of our grid between now and 2040, which is essentially tomorrow, with these dispatchable resources. I also want to point your attention to the fact that this is really a time where we need to be paying attention as an industry, the greenhouse industry, the CEA industry, because right now, absolutely critical decisions are being made in the regulatory arena, the regulatory proceedings, and the market rules that are being established by the New York ISO and by other ISOs. For example, here I'm highlighting on my left the New York Public Service Commission. As I mentioned, they opened this proceeding on leveraging new clean energy technologies for the zero emissions grid. That proceeding was initiated about a year ago. And we have a big deadline coming up, January 21. There are comments on what is a defer. I would think would be very important to this industry, among many others, to be clear on your ability to operate in these industries and by the way, be well compensated for it. Over on my right-hand side, I'm showing a more recent, this was an October 14th podcast by the New York ISO. They've recently launched a groundbreaking DER program. So markets are changing dramatically. We did an event on CEA with the New York ISO some time ago, and one of the system planners there said that you can expect the grid markets to change more in the next 3 to 5 years than they have in the last 15. And that this kind of resource, were you able to do it, a resource that can be connected to the grid, take a signal, ramp up, ramp down, put more electricity into the grid when it's needed, or absorb electricity when that's needed, you will be paid handsomely for that. Again, our hypothesis is that CEA may have flexible loads. That is, you may be able to ramp the lighting up and down. You may be able to play with lighting recipes to reduce demand. You may be able to install thermal batteries, thermal storage to allow a heat buffer to be utilized to provide more of a decoupling from the energy use in the greenhouse with the immediate use of power. And if you can do that, I want to point your attention to on the left-hand side in the gray. This was a statement from that joint event that we held. This was the New York ISO. Within the class of dispatchable resources, the most reliable ones are those that are already online. Particular value, dollars, particular value will be paid for assets that are online, serving a load, and are able to shed some load and inject that into the grid. So if this is feasible, it's something we feel that the industry ought to be paying more attention to. Jim and myself and Jacob have done several papers. We have several examples of this, mostly from the EU and elsewhere, where there is either co-location with data centers or where CEA sites have organize themselves to take grid signals and to provide load flexibility and dynamic resources to the grid. So again, we feel that there are some opportunities here to affect change. CEA with on-site power can create multiplicative benefits. Putting it together in co-location with other industries, for example, data centers, could certainly augment those benefits. This is a really urgent set of needs. And in the words of the ISO, we're facing a scale of development that's absolutely unprecedented. So with that, I'll hand it back to Jim for some examples, and then Jim will introduce Jacob and his research.
Thank you, Tom. Let me go down. We're just going to give a couple of concrete examples here of stuff that the Mid-Atlantic, New York, New Jersey Onsite TAP Center has done. Not sure why that went that way. Okay, there we go.
Oh, go back just there. There you go.
Okay, one more. All right, so this was a town in Pennsylvania, Quakertown, Pennsylvania. And it was a large manufacturing plant, a family-owned manufacturing plant that made specialty chemicals, specialty leather. And they were looking at reducing their carbon footprint for their processes. So they were looking at on-site energy. Well, they had a lot of thermal demand at the site. We went in and looked at the thermal demand and the electric demand at the site and spec'd out preliminarily a combined heat and power system that could meet almost all of their thermal load and a lot of their electrical load. If we spec'd out they said, well, we want to do all our thermal loads. So we made the engine larger. And when we made the engine larger, we got all the thermal they needed for all their processes, but we were over generating electricity. This particular facility was in a town that was a municipal grid. So they opened up discussions with the municipal grid operators and said, look, we want to do this because it'll reduce our carbon footprint. It'll reduce the cost of our manufacturing. It'll increase our employment at the site because we'll be more competitive. We'll have more sales, especially in Europe. Would you take our extra electricity that we would be producing from this CHP system and use it in your municipal grid and buy less off of the central grid system. The town was interested because they had had several brownouts and even blackouts during some weather events. They were looking for a way of keeping their critical facilities operating during these brownouts and blackouts. So they said, yes, but we would like more electricity, and you have a lot of flat roof space. What about putting solar arrays, letting us put solar arrays on those and selling us even more electricity when you have it? So I don't have the picture here. I couldn't get it to transfer, but they put solar arrays on every flat area they could find. And this CHP system was producing, capable of producing 1 megawatt of electricity. They got another megawatt from this solar. That also was put back into municipal grid, which paid a competitive price for it, but competitive for the manufacturer, but it reduced their costs and purchases from the central grid. So that was kind of a win-win. This is another site. Again, it's in a municipal grid area in upstate New York, and it's a huge manufacturing complex here with an unusual set of abandoned factories where they used to make transformers and, believe it or not, torpedoes during World War II. They're converting part of that huge facility. We're talking 1 million square feet here, just in this abandoned facility. I'm not talking about the surrounding industrial facilities, which may become part of this on-site energy system. But this particular case here, they took part of the facility and they made it into a combined indoor agriculture and fish farming operation. And they buy electricity now off the grid, but they want to rapidly expand this area. They have a huge amount of area. So they're looking at teaming up with a data center investor who would use part of the site for a data center, and the rest of the site would be used for indoor agriculture or fish farming in sort of a synergistic fashion. That facility then would be teamed up with the surrounding galvanizing and metal rolling facilities, plus several other types of industries, to form their own little on-site energy system, part of which would be CHP, part of which would be solar, part of which would be battery storage. So it's just interesting that you can come up with these creative configurations, these hybrid configurations, which turn out to be win-wins for a lot of people. So again, it's distributed energy, on-site energy in combination with different technologies, controlled environment agriculture being one which we think has a lot of promise given their experience with it in Europe. With that, I'll pass it over to Jacob, who's done some research in the area.
All right, thanks, Jim. Share this. All right, can we see that?
Yes.
Okay.
Yeah.
Yeah, so as mentioned before, I'm a PhD candidate at Penn State studying under Jim, and my research is really focused on on-site energy, particularly in CEA applications. And more specifically, we've really focused on CHP, combined heat and power. And I've been working on developing a model to make energy optimization in terms of energy dispatch at CEA sites. So we see CHP as having the potential of providing resiliency and efficiency at CEA sites, and also being part of a microgrid or smart grid and providing resiliency and efficiency to other sites and to the grid in general, hopefully contributing to the food, energy, water nexus at large. So a brief background on CHP. CHP has been used for a long time because its efficiency is higher than the separate heat and power efficiency of getting your electricity from the macro grid and your heat from a boiler. And I would say these statistics from this graphic are actually a little bit outdated, and the efficiencies that are reported today are much higher on both ends, but it still stands true that CHP is significantly more efficient than separate heat and power. Now, CHP has definitely gained traction in the CEA industry, particularly because in addition to the heat and power, when you're burning a hydrocarbon fuel, you get the CO2 as your exhaust. And so now we end up with something like tri-generation instead of cogeneration, where we're able to use the heat, the power, and the CO2 all to inject into the greenhouse. Something that's gained some popularity recently and is also used in the CA industry due to the cooling needs is absorption cooling. So we can use the CHP device, combine heat and power to essentially create quad generation and actually have heat, power, CO2, and cooling, which are obviously supplying a lot of the environment, a lot of the demands to create the environmental factors that we'd like to see inside a greenhouse. So as we move forward, what gets interesting in terms of on-site energy technologies is partnering this CHP. Once we have all those capabilities with the CHP, are we able to potentially decouple? Jim mentioned that it's advantageous for us in terms of efficiency when both the thermal and the electric demand line up. But what happens when they don't? Can we use other storage techniques or utilization techniques to create higher efficiencies when these demands do not line up? So we're talking about battery storage, thermal storage, the absorption chiller that I mentioned before, and potentially carbon capture, utilization, and storage as well. And using these technologies with CHP to create a higher efficiency at the CEA. Now, this gets really interesting when you're able to partner it on a smart grid or a microgrid that's able to optimize its control. And that's sort of where my research is founded in. So what I've worked on is developing a model to basically simulate what is happening when we want to trade energy between all of these different technologies and show where the flow of energy goes and how it can be used. And then use that in a optimization virtual model to tell us what's the optimal for cost and emissions way that we could dispatch this energy to make it just the most efficient way for the operator at the CEA site. I wanted to present a few results from a case study that I recently conducted. So we had a 25-acre tomato greenhouse modeled for State College, Pennsylvania, because we're here in State College at Penn State. And I was fortunate the TNO partnered with me to give me a model for what the energy demand would be at a site like this in State College. And these are the electric demand, cooling demand, heating demand, and CO2 demand for every hour of the year. So we're working on an hourly time step. And then we took I think 26 different simulations, different combinations of auxiliary technologies. Auxiliary technologies are what I call the technologies in addition to the CHP, like the storage technologies. So in the top chart here, you can see how each technology works with the CHP and how effective it is in terms of reducing the costs and reducing the emissions. In this specific case study, we saw that the thermal storage was actually the most effective technology and was able to reduce costs significantly. And then we can run the same simulations with multiple technologies to see if there's synergistic effects or if they're not working well together or if they complement each other. So in the table on the right, I show that without the CHP, the annual energy procurement costs were about $3.3 million. And by adding the CHP, we were able to see a reduction of 12.5%. Then adding the thermal storage for heating onto that system, we were able to see an additional 6.5% reduction in costs. And then we continue with the battery storage and the carbon capture systems. Now, what we did see is as we added more technologies, actually their individual effects were lessened. So there weren't necessarily synergistic effects of adding technologies. but they each are able to still contribute to lowering costs and lowering emissions. One thing I want to be clear about, though, is that the capital costs were not included in this study. This is strictly optimizing for energy procurement costs operationally. The next thing that we did was we looked at how would energy market participation affect the optimal operation of these systems. So we ran 7 different simulations here with the CHP thermal storage and battery storage system. And we increased the market price factor. So the market price factor is how much we could sell electricity for in comparison to how much we can buy electricity for. So if the market price was 10 cents per kilowatt hour, and we have an 80% market price factor, then we're able to sell it for 8 cents per kilowatt hour. Now, interestingly, in our case study, we actually didn't see a huge impact based on the market price factor as we start to sell electricity. We did sell a lot more electricity as we're able to sell it for a higher price, which is expected. And there are a couple of reasons that this impact was not very high. Part of this is that this simulation had the battery storage. So there are a lot of time steps where it doesn't make sense to sell it to the grid because we can store it and we can use it later. Additionally, I think maybe the most important is the spark spread. The cost of energy here in Pennsylvania for this, what was input as the prices for electricity and gas in this case study just made it not very profitable to purchase gas just to create electricity and sell it. So if we can use the battery, we'd rather use that. And it's not going to change the overall financial balance of the system. However, I would like to note that the Netherlands, which is obviously a leader in the controlled environment agriculture space, experienced a boom in the 2000s because their energy market opened and they were able to start selling energy. And you also see a tremendous amount of CHP capacity be added in that time. And I think it's really telling when you look at the statistics that say eventually in about a 5-year period, they went from opening their market to having 10% of the nation's electricity be provided from CEA sites. So what we can see with that is that actually CEA was contributing to the rest of the country in the electricity demand and providing reliability and resiliency on their grid. Now, another interesting thing we saw here as we look at the energy market participation down in the bottom right is that actually the thermal storage and the battery storage were used less as we sold more energy. One of the reasons for this is that we would just rather use the electricity when it's made. And I think a big note to keep in mind here is that what we're seeing with these case studies is that there's a lot of things that aren't necessarily what you would think of what you would immediately think. So the optimization provides a different look at how you would optimally operate your systems to get the lowest cost. This is a more detailed look at some of the data from a specific day. So we have March 20th modeled here. And I think some of the interesting points are if you look at hour 16 in the bottom left, we're overproducing heat. And you might ask, why are we doing that? And then if you look at the top right, you see that we're doing it because we're trying to meet the CO2 demand during that hour. In the top left, we have the electricity balance. We're overproducing electricity, but it's because we can store it or we can sell it during those time periods. And again, I don't think all of this is intuitive, which is why I believe this research is important to help operators and developers understand how these technologies could benefit them in ways that we might have not understood before. In the bottom right, we have another interesting graph showing how thermal storage was used throughout the year. The most interesting part to this graph for me was actually that the thermal storage is not used heavily during these winter months of January and February, but it's used the most during the spring and the fall. And the reason for that is that if we're making heat during the winter, we're going to use it. We're not going to store it. We're going to use it at the time that it's made. And that's another thing that I think kind of defies what you would intuitively think in terms of the time that thermal storage is most useful. So next, I just want to kind of go into where I see this research going forward. Hopefully we can use weather predictions and greenhouse energy models like the one that has been developed with Glaze GEM, I believe it's called, and use those with a model predictive control and an energy dispatch optimization like the one that I just presented, and forward energy markets. If we look at day ahead markets or week ahead or even year ahead markets, to continuously update this optimization and hopefully use it to help operators run the system in the most effective way. And the other way that we can use this, I just mentioned optimal operation in terms of energy procurement and maintenance. And the other thing is design. There might be some ways to use the systems that we did not anticipate before. So in terms of equipment sizing and demand coupling, using these technologies, these models, might help us to produce better designs for CEA in the future. I wanted to give a few quick examples of companies and groups that are already doing putting this theory to work. So we've worked with Jenbacher and AB Energy. These are two companies that are providing the energy. Jenbacher is obviously an engine manufacturer. And they have a lot of examples of CEA sites that they're operating CHP at. You can see some of those sites in the pictures on the right here. If anybody watching this has any information on these, I would be very interested to talk about it at some point because they're actually claiming efficiencies of over 100%. But the point is that they have very high efficiencies and they're able to really contribute to the CEA. In addition, I'm actually doing work with Energy Acres and Project Everberry, which is a group that's combining data centers and greenhouses and looking to put CHP in at those sites and energy storage to provide the energy resiliency and reliability that the data centers need, but also give CO2 and heat to the greenhouses to couple those loads like we mentioned before. So I did want to touch on that real quickly. The combination of greenhouses and data centers is something that's becoming very popular recently. Like I mentioned, we're working with a group right now on a site in Ohio. And one of the reasons for this is that the data centers constantly need power and they constantly need cooling, and the CHP can provide those things efficiently. And then we might be able to use the CO2 for the greenhouse and use some of the recycled heat from the data center at the greenhouse as well. So I just wanted to put this, I'm sure some of you have been thinking about this, but I wanted to put it on people's radars because it's definitely been talked about a lot in some of the spaces that I'm in. And lastly, I just wanted to touch on the decarbonization of controlled environment agriculture. Obviously, I presented research with hydrocarbon combustion, and I think that could be definitely a gateway to us decarbonizing the rest of the grid. As Tom mentioned, having these dispatchable resources is really important as we have the variability in our sunlight and wind. But as we move forward, we need other solutions that are going to be clean for the future. And one of these solutions is just clean combustion. Can we use hydrogen? Can we use biogas, landfill gas? And there's also a lot of discussion in the meetings that I'm in about renewables and electrification, specifically heat pumps and geothermal. I did want to quickly just highlight the biogas and landfill gas because one thing that this could enable is using the rest of the research that we discussed and still providing CO2 and also reducing the methane that those gases would produce otherwise and transitioning that to CO2, which is has a much lower global warming potential than methane. So that's it for me. Thank you all. Thank you for listening to the research, and I'm honored to be here.
Thank you very much, Jacob. It's very interesting, of course. If you want more information on the Onsite Energy program, you can go and visit these web pages or these fact sheets. Go to DOE. There's plenty of sites. Just type in DOE Onsite Energy Centers. They will take you to a number of websites that you can find more information on. These are our program managers in the DOE headquarters. There's a lot of contact information here. There's more specifics within the site. You can get a lot of information on a lot of different technologies that we consider at these sites. If you want to, next site, if you're in the next slide, if you're in the if you're in the New York, New Jersey area or the Mid-Atlantic area, you can contact us. We gave you the information earlier on in the slide deck in terms of contact information. You can contact Tom, who's been working in the area for a number of years, and a lot of you probably know him already. And if you want to take a look at this technology for a particular site, just contact us and we can discuss it and then go from there. If you want to learn a lot more about CHP and CEA or other forms of energy with CEA, then contact Tom or myself or Jacob in particular, and we can discuss that with you. So with that, I think I'll just be quiet and see if anyone has any questions.
Thanks so much. I'll get us started here. Appreciate the presentation, and I'll start with just a question for our attendees if folks want to write in with an answer here. And we're curious if anyone on the call is using CHP or any on-site power, and if yes, do you export to the power grid? So feel free to let us know via the Q&A, and then I'll ask a question to our presenters here. Jim, I saw you address this in writing, but other folks might have the same question. So I'll read it here just so that the whole attendee list can benefit from it. So someone asks if they work at a university research facility, and the question is if the program is valid for that type of operation, and then the follow-up question is there a program available outside of New York, New Jersey, or is there another regional program for North Carolina?
Yes, and the answer is yes to all of those. The on-site energy assistance is available to any facility. The ITAC grants are available to any facility. The ITAC industrial assessment centers can help you pass the feasibility for your application for those grants, as can the on-site energy centers. We're one of the two organizations that can get you started on that. You would actually fill out the application, but we would come and do the on-site assessment, say, yes, this facility is actually eligible for such grants, and then you take it from there. Aside from the specific grants, in terms of technical assessment and economic assessment on on-site energy, that's any facility, so that's available. And there's 10 regional centers around the United States. You can contact your local regional center. I think for North Carolina, it'd be the Southeast Center. And that information's on the web, right, Tom?
Yeah, yep. That would be the Southeast. That would be based out of NC State. I think Joe James and Jameson Hill have questions. If
Okay.
I see hands raised.
Jameson, I just clicked to allow you to talk. We can try it that way, and if you have any difficulty, write in your question.
Yeah.
Okay. Yeah, I was the guy that actually asked earlier. I asked anonymously in case somebody else also have had the same question. But I know in New York, all right, through NYSERDA, there's like a Flex Tech program that basically, you partner with a outside firm, right? So you're the building owner, right? You partner with a firm, Flex Tech partner, right? That then does an energy audit, come with a list of recommendations. Then, you get an incentive to pay for the audit. Then later on, there's incentive to pay for the implementation. I'm wondering, as far as with the on-site TAP program, if you guys have a similar arrangement because I would like, sort of as a business development thing for the company that I work for, we would like to move a bit more into the industrial sector, and I thought that might be a good way we can, sort of like, you make some of that transition and also, find potential clients that way. Is that done, or is most of it kind of done in house?
Well, we would come to your site. If you had a particular site or a particular set of sites you were talking about, we would do the assessment in terms of the feasibility of on-site energy implementation. And then whether you would want to get like a Quakertown example I gave you, whether you'd want to generate additional electricity and whether that would be economically feasible for that site given that particular utility. Each utility will have their own little set of hoops you have to jump through. I'm sure you know this in terms of interconnect and
Okay.
sellback, et cetera. But we do that on a site by site, utility by utility basis.
Jameson, I'll just add briefly to that. I know the Flex Tech program quite well,
Oh, hey.
we like to. I think the way we like to put it is that we work in partnership with them. It's not us or. It's not
Mhm.
either
Okay.
or. It's a both and. They do different things. We do different things. One of the things that we may do that may be additive. So, for example, let's say you get some assessment from someone, and we serve. And Jim mentioned this. We are an unbiased, third party, arm's length assessor,
Well,
and we can put our eyes on it.
okay.
Mhm.
So it can be, kind of that second look at no cost. We are no cost. Um, so we don't want to leave the impression that we are a replacement for FlexTech. We
Oh,
are.
no, 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 no. I was just wondering about if it's
Okay.
possible for us to work for you guys, basically. It's kind of more my question.
Yeah. No, no, um, we offer something that's quite synergistic, we believe.
Okay.
Yes, that's right.
Thanks, Jameson. Joe, I saw you had a hand raised as well, so I'll open things up for you, but I know you've also posed a question in the chat, which I believe was answered. So let us know if there's something else.
Yes, thank you. I've invented a process by which we plant very fast and large growing biocrops that capture 4 times the amount of CO2 per acre as pine trees, twice as much as the next best crop that we know. And then we harvest the plant material and convert the resulting biomass into biochar. We found that utilities have some interest in this because they surround themselves with lots of underutilized land to both protect themselves from the community and vice versa. So my question, I guess, to Jim or whoever else is appropriate, are the utilities in the New Jersey, New York area that we might collaborate with in partnership with you guys or however the program works to demonstrate the efficacy and measure the efficacy of what I've just described to you?
Yeah, I mean, if depending on the scale factor, utilities and PJ&M and different regional RTOs, ISOs, they're looking for lowering the carbon footprint of their generation. So you'd kind of have to look at that in terms of would this be economically feasible? Would it be a net zero carbon production of electricity using the biochar and maybe gasification of some of the plants, et cetera? So I can't give you a straight answer on that. That would depend on the utility. Uh, but it's possible. Yes, it's
Yeah,
possible.
let me respond and say that we are, if you look at the overall operation,
Yeah,
we're reducing the carbon footprint of the presence of the utility on site by a factor of about 8 tons of CO2 per acre
yeah,
during the growing season. That's just a warm season.
right.
We can also plant something in the wintertime as well that might capture a little bit more. But the crop that we use captures 7 tons of CO2 in the crop material above ground, and the root system captures another ton of CO2 on its own. And it's also able to, through phytoremediation, remediate some contaminants that might be in some of
Yeah,
the sites that
yeah,
the utility has, coal ash deposits, blah, 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 blah. But
right.
Jim, who can I talk to
Uh,
pursue this further?
yeah, give me a call. You sent me your the website of your technology.
Yeah, my telephone number was included, an email address included as well in the chat.
Yeah.
So I'd be glad to get
Okay.
a message from you.
Definitely. I will take a look and get back to you.
Yeah,
I
and
don't,
I do have both a New Jersey operating affiliate and a New York operating affiliate that we can put to work as our company representative to partner in the New Jersey, New York area if that's required.
okay. Is your contact information on the registration too? Do you know if that's true, Matt?
Yep.
It is. So I can go through Matt and get that in case I didn't get it off the chat. That's great.
Yeah, I'm happy.
Yeah. Yeah. Bottom line is we'd love to even do a small test planting this spring if that would make sense for you guys.
Yeah, actually, Penn State might be interested in that. I'll have to check on that. But anyway, let me look at the details and see.
Thank you.
Thank you.
I think my friend Robert MacArthur had a question if he's still with us. Robert?
Yep. So he actually just typed it in. How important is circularity in CHP systems used by CEA?
Jacob, you want to handle that one?
Can you specify? Did you say
Yeah,
circularity?
Yeah, what do you mean by circularity?
I'll take a stab at this
All
one.
right.
And I think Jim Freihaut's right. We have to define our terms. But as I define circularity, I think it's absolutely critical, especially now, as well, at least the states we're working in are all decarbonizing. So we're being told that we want a 100% emission-free resource grid 2040, which again, I'll say is kind of like tomorrow when you think about all you have to build between now and then. So yeah, circularity is important. The ability to use organic matter. Jacob was talking about that. He was talking about the various pathways, biogas, landfill gas, avoiding methane, etc., being characterized. And this is where the rules, I cannot urge enough, pay attention to the market rules and the regulatory structure because it's being written right now as we speak. You want to make sure that you are a zero emission resource if you're using a certified biogas, whatever. You don't want to be written out of that. But yes, I think circularity is extremely important, especially going forward. And I think that it will make for a much healthier CEA industry to put together the circularity with the industry's utilization of energy, thermal and electric.
Thank you. So we are a couple minutes over time here, and I imagine folks have to run. So I do want to wrap things up here and first of all thank our presenters here today. This was very interesting and clearly some good questions from our attendees. So we truly appreciate you taking the time to join us and present. And I also want to thank our attendees for taking time to learn more about this program. This webinar is recorded, so will be posted to our website and available to come back and refer to. And I'm sure our presenters are also available for any follow-up questions you might have as well.
May I leave one last thing? If you want to know more about the grant, as I said, I'll send this around, December 17th, noon and 2 Eastern time, deep dive from the headquarters on how to access that grant, and it is available and has been procured by greenhouses.
Yeah.
Thank you.
Thank you, Tom.
Okay. Well, thanks again, everyone, and I hope you have a great rest of your day, and we appreciate you joining us. Thank you.
Thank you, Matt.
Take care.
Thanks.